Okay then, so let's start the demo, friends. So before going to presentation, so let me discuss what is big data and why big data. Okay, so let's take a small real-time scenario and see how big data is growing and why especially market is looking towards big data. I mean, why companies are looking towards big data, at what purpose. Okay, what is the challenges they are facing with this existing solutions or with the traditional tools. Okay, and what are the challenges even they are seeing in big data. So what are the pros and cons also we are going to see. Okay, so where big data actually fits in real-time scenarios, in real-time use cases. Okay, and what companies are currently using. Yeah, Vasish, do you have any question? Okay, fine. Okay, so let's start the demo. So let me start by taking some real-time scenario. So assume guys, let's take some bank. So let's assume, let's take some what is that, Citibank. Okay, assume a customer visited the bank. A customer visited the bank and he requested for some 2 years bank statement. And he requested for some bank statement. And what happens? The representative will log into customer account. He will take the printout and he will give the statement. So maximum the service request will close within 5 to 10 minutes, right? So this is what generally happens in banks before, even now. But assume if the same customer visited again the same bank, but this time he requested for some 15 years or some 20 years or some 10 years bank statement. Okay, so for some financial purpose he requested for statement, but this time the same representative will say, sir, you are requesting for historical transactional data, you are requesting for historical statement, which I may not provide immediately. I have to raise a request to backend system, right? I have to raise a request to backend system, and the system will process a request and send you your statement maybe in couple of hours, maybe 4 hours or 24 hours, whatever it is. Why is the difference? When he could able to provide the 2 year statement immediately, why not for 15 years or some 10 years or some 20 years? Why can't he do immediately? We know the reason, the data, the recent data like last 1 year, 2 years or maximum 5 years of data. Okay, some 1 to 5 years of data. The recent data, it will sit in our RDBMS systems, right? It will sit in our relational database systems like Oracle or MySQL, the SQL Server, or Sybase, any database, DB2 or Postgres. It could be any database. But if we switch this historical data like 10 years, 15 years, 20 years, 50 years, 100 years, from the day one the operation started of the company, the historical data, it will sit in our backend systems, what we are calling today as data warehouse systems, right? Like the most popular warehouse systems, Teradata, Netezza, Vetica. So like this we have many warehouse systems available in market. So in this scenario, we know these systems will be accessed by OLTP. So the representative will log into account and will give the statement immediately. But here, these systems are designed mainly to develop what kind of applications, guys? Are developed mainly to work with the batch applications. I think most of you may know what is batch applications, right? So batch applications are something they will run periodically. They don't run all the times. They run periodically. They are mostly scheduled applications. Okay, and they are like long running applications. They will run for minutes, hours, even sometimes days. If you go for big domains like banking, healthcare, telecom, the batch applications, they do run for hours and even days. There are applications they will run 24/7, the batch applications. So in this scenario, this guy will raise a request to backend system, so that a request will get processed in batch in the next scheduled time, and you will get the statement. So obviously it will take some time, at least 1 or 2. For example, the best example, our NEFT transactions. So bank to bank transaction, why it's done immediately? Why to bank to other banks? It's a NEFT. So they'll keep all the requests from last 1 hour or 2 hours as one schedule, and they will trigger at a time, right? So batch applications of course will take time. So this guy, when he raise a request, he will get the statement after a couple of hours. But if you come for big data, friends, big data, irrespective of whatever volume of data you are requesting, maybe 2 years, 15 years, 50 years, 100 years, irrespective of period of data, volume of data you are requesting, the big data system can process and give you the statement or whatever the data even less time than what RDBMS systems are taking. It has a capability of process that volumes of data, maybe whatever period of data, whatever volume of data, it can still process even less time than what RDBMS systems are taking, because it's built using a very popular architecture. Okay, and the core architecture, what we say of big data, we say it's a parallel processing mechanism. Parallel processing mechanism. This is a core mechanism of Hadoop. Okay, we'll see what is big data and what is Hadoop. Okay, don't get confused. Okay, right now assume both are same, but I will discuss in detail what is big data and what is Hadoop actually. Okay, the parallel processing mechanism, this is a core mechanism what big data technologies followed, especially all Hadoop technology stack related tools like MapReduce, Pig, Hive, Scoop, Fuzzy, Flume, everything, HBase. Okay, and again friends, remember this parallel processing mechanism, whatever I'm saying, this is something not newly invented in big data. This is something not new architecture or new mechanism that's been introduced and designed in big data. It was introduced in 2000s by Google. Google is founder of the architecture, and many companies are also using this before. Even IBM used it, Oracle used it. Google is still of course using, but Google is more advanced than this mechanism now. But the companies whoever used it before, they have still some other limitations, guys. But this mechanism, this architecture has been implemented in optimal way in big data. This architecture, this core mechanism is being utilized in a more optimal way in big data. That's why it's get very popularity in big data. That's why big data becomes popular of this optimal implementation of parallel processing mechanism. This is playing very vital role in big data success today. Okay, and again, friends, this parallel processing mechanism, what we are saying, right? This is very playing crucial role in big data technologies right now today. But I am saying right now, this is also becoming classic. So this might be will be there for next maybe maximum 2 to 3 years. That's it. This will be there maximum next for 2 to some 3 years. That's it. Because in big data, even more advanced mechanisms, more advanced architectures has been introduced after this parallel processing mechanism. I mean, they are also still do parallel processing, but still they are more optimal than this core architecture. So like what we are seeing, Spark is getting very popular in now in the market. Okay, So, I mean, we have different architectures. We have different architectures, different execution models. That's why architectures plays very important role. So, how good you are in architecture, right? That good you can learn the APIs, do the implementation easily in big data. And most important, if you understand the architectures very in depth, you can do the performance tuning well and good in big data. Because now a ordinary Hadoop guy and a guy who has very good in performance tuning part, there is a huge difference between these two guys. Okay, so when an interview, if they ask questions, if you just explain what is the answer for that question, that's well and good, but that's not expected now. They are expecting the answers like you have to expect the answer, you have to give the answer, and along with that, you have to tell what are the options available, what are the configurations optional, what are the optimization techniques available with that answer, and what you have been used in your projects, and what is the pros and cons of each optimization process. This is what been expected. Okay, so we are going to see many things about that. I mean, many means most of the things in our course. So this parallel processing mechanism, what is this parallel processing mechanism again? See, this parallel processing mechanism, I am saying this is something not newly invented. So even Oracle has in this architecture. Oracle implemented is something called OPS, Oracle Parallel Server. Okay, but still it has some other limitations. We'll discuss shortly. So what is this parallel processing mechanism? In short, to say that, nothing guys, if you have some table, so let's take some database, let's take SQL Server. In SQL Server, I have some table. So I wrote a query, something, no issues to this. Okay. So assume I have some table, employee table in some database. I wrote some query. Select star from employee where country equal to India. So how the query process will happen? In any database, most of the databases, if you go, all the DBs, they follow sequential processing. Suppose if I assume in my employee table I have 1 million records. If I fire a query, the query will process all 1 million records, record by record. It's going to scan and do the check and then going to return the result. But if you run the same query on the same table which is on big data system, I mean in the Hadoop, having same 1 million records, it does parallel processing. So what it does is simple guys, it will split this data, 1 million records, it will split into some n number of tables. You can assume like n number of small tables or n number of small files. For time being, you can assume anything. So assume 1 million record table is split into some n number of small subtables or small files. It's split into some 20. Assume. So if you run a same query here, now it will run that query in parallel on all 20 small subtables. So 20 parts means assume each part will get some point. How much? Some 50,000 records. Right? Each file, each part file, each 20 files I assume, 20 parts let's assume. So each part will get 50,000 records. Now it will fire the query on all 20 parts at a time. So all the query will run in parallel on all 20 small files or small tables, whatever you say, in parallel. So obviously the query latency is going to reduce 20 times. It's going to reduce 20 times. So big data does the things, it will split the data as much as into small parts and it will do the processing in parallel ways. That is the main, what is the technique there. But how this, what is the split will happen, how this parallel processing will happen, this is all part of the architecture. Okay. So, I mean, you will see this, what is the benefit of this parallel processing mechanism when you work with the bigger data sets. Again, remember, big data is good only for bigger data sets. Okay, assume if I have some 100 record table, please consider friends. If I have some 100 record table in Oracle database, if I run a query, if the query takes some 0.2 seconds, If I run the same query on the big data system having same table with 100 records, here it will take some 2 seconds or 3 seconds. You cannot, even the performance will be worst for if you go for big data for smaller data sets. Big data is not good for smaller data sets, smaller tables or smaller volumes of data. It is good for only bigger data sets. That's why if you go for big data projects, what they do is they don't maintain small tables or small things. They will merge. I will discuss more about this architectures later. Okay, how the real-time scenarios will be. It's good for bigger data sets. You can expect very good performance improvement on big data using this parallel processing mechanism. Okay, so this is the first important characteristics of big data. Okay, and next, scalability. Again, we know very important in today's world. How scalable is our solution, our technology? For example, if I go to Oracle or any database, so what is the maximum limit a database can store data? We know first of all why the warehouse systems came into market. The warehouse systems came into market because the limitations available on the DB technologies in terms of volume of data, what they can handle, and the volume of data, what they can store. Suppose if I take a Oracle database, Oracle high-end database server can store maximum 16 TB. That is the capacity of Oracle high-end DB server. Okay, of course 16 TB is not small storage, but if you think from today perspective, the volume of data what is being generating today market by the companies, by the applications, 16 TB is nothing, storage is nothing. And that too, if you see the like YouTube, okay, the main big applications, big guides, Google, they do generate some terabytes of data every day. Okay, so 16 TB is nothing. So what normally they do, if the database server is full, assume I have Oracle server 16 TB capacity, high-end DB server, so one day it's full, what DBA will do? DBA has to add some extra storage to the existing DB server, otherwise they have to keep one more DB server. Otherwise, they have to archive some of the data from this DB server to some backend system. That's what normally they do. If the DBs are getting full, they will archive some of the old data to backend. That means they will move to data warehouse systems, the historical data. Right? Even if you keep one more DB server, so assume second DB server is full, one more DB server, you connected all of them in a network. You connected all of them in a network. Okay, for example, you connected all of them in a network, one more DB server, one more DB server, one more DB server like this. So maximum Oracle can support 256 DB servers in a network, guys. Again, there is a limit there. That means it can support maximum 256 into 16 TB of data, even if they go for some big kind of cluster setup to manage fused data sets. Still there is a limitation on the, what is that, network size, cluster size, and the volume of data what they do handle. Same, even if you go for data warehouse systems. Data warehouse systems, of course, right, they have, what is that, they have capability that they can run on any number of, so first of all, to understand, we need to see how the data warehouse systems looks in real time, guys. Okay, even this is important. Why? Because is Hadoop also follows similar infrastructure what data warehouse systems do have. So I think we guys know what is a cluster first of all. So what is a cluster? Cluster is nothing but it's a group of nodes connected in a network, right? So assume this is a small 5-node cluster. So where all the nodes are connected in a network. Okay. So assume this is a this is a 5-node cluster. Okay, so assume this is some data warehouse. Let's assume this is a Teradata system. What is a Teradata system? Okay, so this is a 5 node cluster. Okay, so we know the clusters basically. So if you ask me again, what is a node? Node is nothing but like a one computer case. You can assume like one CPU cabinet. So every node will have its own hardware, its own motherboard, its own processor, RAM, disk, all. Okay, every disk has its own hardware. These are all connected in a network. So every node can interact with each other. They can even exchange information with each other. So this is a small 5 node network running on a cluster mode. So clusters basically runs with the default architecture, that is a master slave architecture. That means there will be one master system that is going to manage the cluster and remaining all will be slave systems. Okay, so these are all will be slaves. Slave 1, slave 2, slave 3, slave 4. So let's assume this is Teradata cluster. So my master has some 4 TB capacity, 4 TB hard disk, and slaves has some 2 TB capacity. Each node has 2 TB, 2 TB capacity. So what is the cluster capacity? So it is 8 plus 4, 12 TB. So one day my my cluster is full. The storage is full. Almost out of 12 TB, some 11 TB is full. What ETL admin will do? The data warehouse admin, simply they will add new nodes. He will add 2 more nodes. He will add 2 more nodes. So like this, he can keep on adding the nodes to the network. 2 more nodes. If this node's full, 2 more nodes. So what is the maximum? If you go to the warehouse systems, even Teradata or other systems, Teradata if you take, because there is a Hariprasad, just a second guys. Hariprasad, you are requesting me to make you presenter. May I know why? I don't know whether.
No, sir, sorry about that.
Okay, sorry. Fine, thank you. Okay. So what is that? Yep. So if you keep on adding the nodes, so even the Teradata, if you take, it has a capacity of, it can support maximum 512 node cluster guys. So it can support like adding 2 nodes, two nodes, maximum 512 node cluster. So basically it is not a limitation. Okay, even it can support more than 512, but the Teradata, the technology, that the architecture, whatever is built, it is designed to handle maximum 512 node cluster. That's it. So if you cross your cluster more than 512 node, still it can work, but you cannot expect the performance. The performance will go down. So even the volume of data, if you go for Teradata is designed to handle around average of 25 TB of data maximum. If the more than 25 TB is crossed, still it can handle, but we have to take care of. It will not. It will not guarantee the performance. We have to take care of performance part. The architecture, the technology is built to design maximum to handle 25 TB data on around 512 TB, 512 node cluster. This is the specification given by Teradata itself. And moreover, assume guys, the major challenge in these warehouse systems, okay, so when the cluster is full, when the ETL admin is keeping adding nodes like this to the cluster, suppose now the ETL admin added 2 more nodes, right? He added 2 more nodes here.
What is an ATL admin, sir?
ETL admin means it's a data warehouse admin, Panaya. He is a admin for data warehouse systems. ETL means, okay, you are asking what is ETL. ETL means it's a name for data warehouse systems. We say it's extract, transform, and load.
Okay.
Extract, transform, and load. Yeah. Okay, so when he is adding the nodes to the clusters, there will be certain downtime, guys. That means they have to go for maintenance mode. They at least for half an hour, for 1 hour, they have to restart the system completely when they are upgrading the cluster. That means when they are adding nodes, when they are removing the nodes, when they are even upgrading any software, they have to do some maintenance. There will be certain downtime. But the major challenge on the Terra on this warehouse system is, as I said, they are mainly designed for batch applications. Okay, so there will be customers, they will be running the batch applications all the times 24/7. So getting some off time to do this maintenance is little challenge. So that's why they will do normally off hours, maybe on weekends, or sometimes they will ask the teams to stop all the applications and then they'll do the maintenance and then they will start the applications again. So there will be certain downtime because admin has to do some restart activities. But if you come to big data, the first point is big data don't have any limitations on the cluster size. It don't have any limitations. It can run on thousands and thousands of nodes of clusters. And today, the biggest cluster is running on big data by Yahoo with 45,000 plus node cluster. 45,000 plus node cluster is running by Yahoo on big data. Even Facebook is running with 28,000 plus node cluster on Hadoop. Even eBay, many companies, Amazon, there are many clusters running with thousands of nodes on big data. Even banking, many of the banking sectors, they are running big clusters on big data, like 200 nodes, 500 nodes, 1100 nodes. Okay, so they don't have any limitations as of now. And moreover, see friends, whenever, suppose assume now this is a big data cluster. Okay, till now we assumed it is a Teradata cluster, right? Let's assume now it's a big data cluster, Hadoop cluster. So same, I have 5 node cluster, so 12 TB capacity. So one day my big data cluster is full, Hadoop cluster is full. So Hadoop admin added few more nodes. But here Hadoop, when adding the nodes, Hadoop admin don't need to do any maintenance, 0% maintenance. That means when the nodes are added to the network, Hadoop master architecture, okay, the master architecture part has the intelligence. Dynamically, it will detect the nodes that is being added to the network and it will start utilizing it. Without a single command, without any restart, without even a single click from Hadoop admin, the architecture has a mechanism on the fly. It will detect the nodes that is being added to the network and it will start utilizing it. There is 0% maintenance, no restart, no nothing. So the current applications, they can run as it is without any disturbance. It has that mechanism, guys. The architecture, the architecture in master has that intelligence. And Hadoop, in Hadoop, we say it's a horizontal scalable architecture, guys. It's a horizontal scalable architecture. So you guys may heard about vertical scalability, horizontal scalability. So first of all, what is vertical scalability? Vertical scalability is nothing but, as we discussed before, if the node is full. So if your 2 TB is full, you can add one more disk to the node, one more 2 TB disk. If that is also filled, one more 2 TB. But still there will be a limit, right? So if you keep on adding the disk that is not sufficient, you have to add the processor capability, you have to increase the RAM capability. But still, even if you keep on adding them, there will be certain limit on this hardware. Not only vertical means not only that, even vertically adding nodes like this. Suppose why not adding nodes? Why to add nodes like this side by side? Why not? Can't I add one more node down to this node? So can't I add nodes like this vertically one by one down to the network? You can add this. But if you go to real time, so let me show one diagram quickly. Yeah. So this is how real-time Hadoop clusters looks like. So this is one vertical nodes. We see set of nodes here, each one is one node. Vertically there will be certain limit, guys, but that is depends upon what rack technology you are using. So in real time the Hadoop clusters will be maintained in racks. So for example, so there will be one rack like this. In racks we'll keep the nodes. Okay, so there will be a rack. So here you are seeing in the diagram, right? This is one rack. So there will be limitations at the rack level. So it depends upon what rack technology you are using. There are very popular rack technologies available in market like RAID, redundant array of independent disks, JBOD, just bunch of disks. In our course, we are going to see them in the Hadoop admin topics about the rack architectures in detail. Okay, so it depends upon the rack capacity, but every rack architecture has certain limit on the rack level. So there will be limitations at the on verticality. Vertically, if you want to add hardware or if you want to add new nodes to the racks, there at certain time there will be certain limit. Okay, if rack is full, you can add one more rack, adding new more nodes. But horizontally, you can add any more racks. Suppose if you see this cluster, one day if this cluster is full, they will add one more rack. That's it. They will keep on adding the racks. Adding the racks means adding new nodes. So that's why Hadoop, we say it's a horizontal scalable architecture. So horizontally there is no limitations. It can keep on adding the racks and new nodes to the racks. Okay. So this is also playing very important role in big data success. And next, most important, hardware failures, which we also say as a fault tolerance. Right? Very important. So if you take a database case, suppose assume if your DB server is down, we know what will be the impact. Suddenly assume my Oracle DB server is down. So what will happen? You know the impact of the systems if the DB is down. So all the OLTP applications, the online transaction applications, that means the real-time applications which are dependent on these databases, they will be down. Of course, nowadays the DBs are also very advanced. They are maintaining the standby servers, right? Failover servers. So if the main DB server fails, there will be a standby server, the backup server that will be play active role. We know we have active passive architecture, standby architecture, failover architecture. So if main DB server fails, the backup server plays an active role. But assume, guys, unfortunately, at one time, both your main server, main DB server and the standby server both are down at the same time. Both the main DB server and standby server are down at same time. But in that case, there is no option. The application should, it's happened recently in many applications. It's happened in Flipkart, it's happened in Jet Airways because of huge bulk, what is that, orders, and due to some festive seasons in last year. Okay, the load balance server and the main server both were down at a time and the applications were down for a couple of hours. And it has a huge impact on the revenue and as well as fame. So coming to warehouse systems I said already. Suppose assume again this is a Teradata cluster. Assume some Teradata application is running. But these warehouse architectures are fault tolerant, guys. Okay, they are also able to handle the hardware failures. Teradata is very good in that part. Even Netezza, they are fault tolerant architectures. Just like Hadoop, right? They are also fault tolerant. So in that case, they are also good, just like Hadoop. That means basically when applications are running, suddenly if the nodes are down. So assume some Teradata application is running from last 2 hours. Almost some 90-95% of the processing is completed. Suddenly one of the node in the cluster is down. So that application to finish remaining 5% of the processing, it needs some data from this node. So what should it do? It will try to access and it should fail. But this guys has that mechanism. They will handle that hardware failure. Similarly, Hadoop also does that. Assume if some Hadoop application is running from last 10 minutes, So suddenly the application is down, suddenly one of the node in the cluster is down because of some issue, hardware issue or network issue. So that application needs some data from this failed node, but still Hadoop can make sure that application will get successfully get executed and get the results generated without any impact, using a very powerful feature called replication. So the same replication feature is also available in Teradata and Netezza, but with different technology and with a different approach. So the replication means nothing, guys. It's a duplication of data. Hadoop maintains a duplication of data, but where exactly the duplication will be there, how it will manage, that we'll see it later classes, because that is a huge topic. And next, cost. Again, very important. So of course we know the DB technologies. Okay, that is we cannot escape. Of course we need to invest there, because any application to run minimum they need a DB server. But that is a single time investment, but they have to pay again every year for license renewals and support. That is actually a little costlier for license renewals and support every year, right? And even if you go for data warehouse technologies, these tools are very costlier, guys. If you go for Teradata, Netezza, these solutions are very costlier. The problem is, if you go to these solutions for any analytics or any operations, I mean to implement the project, it's not only software, it's not only tool. You have to go with their own hardware. You have to purchase from end to end appliance from them. That means you have to go their own hardware, their own, of course, architecture. That means the softwares, Teradata application, APIs, and even the license is costlier, support is costlier, even the resources are also costlier on these warehouses. For example, to make it more simple, if you want to set up a Teradata cluster to process around 25 TB of data, you need to invest maximum around 3.2 crores of amount. So this is a average investment required for handling 25 DB data on Teradata cluster. So to compute 1 TB data, it needs around 16 TB, so around $16,000 to compute. I mean, I'm not talking about storage. Just to process 1 TB data, it needs around $16,000 cost on Teradata. But if you go for big data, if you want to put a same cluster setup for 25 TB data, it will be done around something 1.3 crores, 1.3, even less than that. If you want to process some 1 TB data on Teradata cluster, guys, 1 TB data on Hadoop cluster, it's going to cost around $3,000. This is the industry specification. But if you go for Teradata kind of systems, it costs around $16,000. So it's very cheaper. It's more than 4 to 5 times cheaper coming to big data. That's why most of the warehouse projects, mainframe projects, are migrating to big data, because they are seeing the cost benefit. Good cost benefit. The reason why Hadoop is cost effective, why it's could able to do that, is because the Hadoop is designed to run on commodity hardware. Commodity hardware means cheap hardware. Hadoop don't have any hardware limitation saying that, boss, I need this hardware configuration, I need this hardware model, I need this much RAM, this much processor capability. Don't have any limitations like that. It can run with any kind of hardware. It can run with even cross hardware platforms. I mean, different nodes with the different configurations, different hardware models in a cluster also it can support and run. It runs on a commodity hardware which is very cheap. It's actually Hadoop is recommended to run with cheap hardware. Run as much as cheap hardware. Okay, but in cheap hardware also, if you go to real time, in the cheap also they will choose the best hardware in the cheap, I mean in the less cost. Okay, they will not go very cheap hardware, because in real time, of course, we'll be discussing there are some standards. okay, coming in terms of commodity hardware as well. But it's very cost effective, friends, the commodity hardware. So I see in my experience the projects which migrated from mainframe to big data, they are saving around 65% of the cost, whatever they used to spend before on mainframes. Even that's why if you see IBM, right, stop supporting, IBM is giving more priority now. IBM is their own Hadoop again. I will be discussing shortly about the distributions. Not only even data warehouse systems, they are migrating, slowly migrating to big data. That is still in progress, because migrating from a data warehouse into big data cannot be happen on a single night. It will take months, maybe even years. If it is a very, it depends on application scope and the volume of data what they are handling already, and volume of applications what is there already on warehouse systems. Okay, but the problem with the commodity hardware, there is the challenge with the commodity hardware is that as it is a cheap hardware, there will be, it's not a reliable. There will be chances of more frequent failures. The hardware may fail very frequently, right? Of course, we have to agree. If it is a cheap hardware means there will be chances of failing very frequently, as it is a not reliable hardware. But Hadoop has again solution for hardware failures. So these two features are complement to each other, guys. And these two features are playing very important role in today big data in success, in Hadoop success. And these two are the reasons why customers are coming towards big data. Why? Because any customer finally expects two things. One is he wants his system to be 100% available, 0% downtime, and he wants the things to be settled as much as less cost. Okay, so this also plays important role. And next, friends, what is that? Yeah, volume of data. So big data can handle any volume of data today. It can handle GBs of data. I mean, there is no limit as of now. GBs, terabytes of data it can handle, petabytes of data it can handle. It can handle exabytes of data. It can handle even gigabytes of data. Even it can handle yottabytes of data. Of course, we don't have any applications handling gigabytes of data, but there are applications handling exabytes of data and big data and Hadoop by Facebook, okay, Google. Okay, so many of the what is that big guys are handling terabytes and petabytes of data and big data, and small range companies are handling GBs and terabytes of data on Hadoop. And next, very important, type of data. So friends, maybe in your experience till now, whatever you work, mostly you would have worked with databases, right? RDBMS systems, or maybe warehouse systems mostly. So you guys know what type of data these systems will deal. So maybe you deal mostly with these systems. You deal with relational data, right? So this system supports mainly only the relational data. Relational data means structured data. The data which have some well-defined schemas, metas, okay, easy to process, well, rules, ACID rules, normalization rules, all these things. Okay, so big data is designed not only to process structured data, guys. Big data is designed mainly, it has the capability to process unstructured data and also semi-structured data. Yes, Panaya, you have any question? Malati, you have any question? Malati, can you go to mute?
No, no.
Okay. Okay. So big data is designed mainly.
Continue, sorry.
Sorry, please repeat. Okay. So big data is mainly designed not only to process structured data, it has the APIs, it has the solutions available to process structured data, unstructured data, semi-structured data. And friends, remember, today the unstructured data plays very important role in data analytics. And if you see the volume of data what is available in total world, if you see the majority of data is unstructured, not majority, it's most. If you take the total data available in the world as some 100%, right? So in that 80% of the data is unstructured only. Only the data what you are using day-to-day operations in your databases or maybe through XMLs or JSONs, right? It's just 20% data that is structured and semi-structured. Why? Because such a huge unstructured data is because the sources who generate unstructured data is very huge number of sources are there. For structured data, the sources are nothing but our databases only and data warehouse systems mostly. But if you go for unstructured data, the sources who generates unstructured data is very huge number of sources. If you take, for example, satellite data, satellite images, GPS data, sensors data, social networking data, tweets, images, videos, charts, blogs, graphs, military surveillance data, geological surveillance data, biological data, call center data, logs, application logs, web logs, mails, spam messages. Of course, messages will come in terms of in group of charts, mails, logs, server logs. Okay, if you see, this data is completely unstructured, and you know, currently the competition is going between the people who could able to utilize this unstructured data very efficiently. Who could able to utilize this unstructured data and who could able to analyze this unstructured data very efficiently, they are gaining the market very fastly compared to others. Because analyzing unstructured data is not as easy, because this data could be again in different formats. It could be in text format, it could be in some raw format, flat format, image format, video format. And in videos we have different formats, we know, images. So we should able to analyze this unstructured data as well as structured data and semi-structured. Semi-structured means basically XMLs, JSONs. We have still some more formats in semi-structured. So Hadoop has solution to analyze any type of data, guys, which is, this is not at all completely available in the warehouse systems and RDBMS systems. And last but not least is application development time. Okay, so please consider it, guys. So Hadoop is mainly designed to do data analytics, guys. So in this analytics, we have data analytics. Even we can use Hadoop for data services and even for data operations. But operations right now it's been utilizing very less, mainly for analytics and data services. Okay, so again coming to data analytics, we have different types of analytics. As we know, the batch analytics, as we discussed for warehouse systems, and near real-time analytics and real-time analytics. Batch analytics, real-time analytics, near real-time analytics. Okay, real-time analytics. So again, to do this analytics, no, the reason why again Hadoop is getting more familiar, one more reason is Hadoop is not a single solution technology. If you want to do analytics in Hadoop, you have n number of alternatives are available, n number of frameworks, n number of APIs, n number of solutions are available to implement analytics. Analytics are data services or even data operations. You have n number of solutions, guys. If you want to implement analytics in big data, right? In Hadoop, you can do in MapReduce. MapReduce is one of the option, one of the alternative to implement the project. You can do in Pig. Pig is one more option. You can do in Hive. Hive is one more option. You can use HBase. HBase is one more option. You can use Cassandra. You can use Kites SDK. You can use, what is that, Impala. You can use cascading. You can use crunch. Even you can use Elasticsearch. Of course, it's a little different purpose for certain requirements only. This will good. Elasticsearch. You can do, what is that, through Spark. Spark again, we have in Spark again you can do using multiple ways. You can do through using Storm. Of course, Storm is for real-time analysis. You can do through Flume, certain requirements. You can do through MongoDB. You can do through CouchDB. You can do through still, we have many things guys, like DynamoDB. Okay. So like this, we have many solutions guys. If you want to implement analytics, and still many are coming. I mean, still some are in implementation. So if you want to implement analytics in big data, you have n number of alternatives. So you may, again, don't get panic. So do we need to learn all of them or what? Okay. So here, again, to learn, the good thing is, all of them are open source. That is the first important. And again, we accept MapReduce. Accept MapReduce, right? We call remaining all of them as Hadoop ecosystems. We call them as Hadoop ecosystems. And every ecosystem is very, very powerful. Every ecosystem has its own API for implementation, has its own framework, and every ecosystem has its own advantages and disadvantages as well. And you know why most of the Hadoop project starts with proof of concept, I mean the prototype? Because choosing what technology, I mean what ecosystem to implement it's a big decision. That's why some projects will spend some months, couple of months, 6 months, 1 year, even I see the project spends for years to see what technology is best for their requirements. No, R is not ecosystem, Sai-Kiran. R is it's a different product. R is a licensed version. Okay, R we have licensed and open source, but it's a licensed tool. So you have R Hadoop is there. R Hadoop runs with Hadoop. R normally it's not a Hadoop tool. It's also one of the analytics tool. Okay, costlier tool. Okay, I'll discuss about R. But R don't have capacity to store volumes of data. Okay, again R with Hadoop is a very popular. R again independently it's not very popular. Again R they have to integrate with some SAN network, a SAS network to do analytics. But Hadoop you don't need again one storage system, again one computation system. Hadoop has all things together. It has its own storage framework, it has its own computational framework. That's why R with Hadoop is very popular again. Popular means some companies are, maybe very few companies are using R with Hadoop. Okay, and I'll discuss now. Even compared to R with Hadoop, Spark with Hadoop is very popular. Is getting more popular because Spark is completely open source. Okay, and we'll discuss about that. So every ecosystem has its own advantage and disadvantage. So companies will spend just to see like which ecosystem is best. And again, see guys, if you go for any Hadoop project, they will not completely implement with one ecosystem. For certain requirements, they will choose Hive. For certain requirements, they will choose Pig. Because for those requirements, you can do still in Pig. But Hive is good for those requirements. Suppose if you want to do querying, Hive is good. No, you want to implement the things through programming, then MapReduce is good. Okay, so it depends upon comfort, it depends upon the resources, competency, and depends upon the deadlines. It depends upon the of course the requirements. It depends upon the type of data what you are handling. They'll choose the ecosystems. If you go to any project, any project will have at least minimum 3 to 4 ecosystem combination, guys. That's why even when you guys by end of the course or maybe by the time you start job trials, you should be strong at least some minimum 4 to 5 ecosystems. But in real time, when you go for Hadoop, position, the basic means the general requirements what they expect is mainly the MapReduce, Pig, Hive, HBase, okay, and Impala, some guys, and Spark is something what right nowadays everybody is expecting, Star, Flume. So these are the basics. I mean, along with this, we have few more things. Those are all not ecosystems. We say Scoop, okay, Scoop, Zookeeper, Woozy. These are all supporting utils. Okay, so they do expect on these things. You should be strong. Okay, you should be well knowledge on these things. Basically, MapReduce, Pig, Hive, HBase. What is that Impala? Impala is not required for all. Okay, some guys only will use Impala. We'll discuss about Impala. And Spark, Storm, Flume, Scoop, Uji, Zookeeper is what it basically is required for any Hadoop position. Okay, and for specific customers, they may go for Cassandra, but in our course, we'll be discussing Cassandra as well. Okay, Kites SDK again, very, very rare. Okay, because this is Java based. Okay, that's why. And it's not fit for all requirements. Okay, it's good for only certain requirements. I will discuss in the course. Okay, Elasticsearch is good for again drilling kind of requirements. If you do any searching, filtering of data, good for mainly for reporting from reporting perspective. Okay, so and again, so what is the prerequisites to learn these ecosystems? So guys, to learn MapReduce we have two parts. One is the architecture part, one is implementation part. Architecture, it's irrelevant to technology. Architecture is purely theory. Okay, architecture we don't touch any Java, all these things. But if you want to do MapReduce programming, you should know Java, core Java. Core Java is well sufficient. In core Java also, you don't need to learn thread programming. You don't need to know socket programming or RMI programming. All these things are not required. So you should be very good in OOPS concepts and Java collections. Okay, that's why in the course I will be taking some 8 to 10 hours of core Java classes. Then I will go for MapReduce practicals. Okay, this is for the people who are from not Java, from Java background. Okay, and MapReduce programming is not only in Java. If you want, you can do in other languages as well. You can do in C++, you can do in Python, you can do in Ruby, you can do in Perl, you can do in Shell. MR programming is still possible in other languages, but in real time, mostly they will do either in Java or Python. Okay, these two are more popular. Mostly Java only. And then Pig is completely new API, guys. Even a guy who is coming first time to IT, even a guy who has some 10 years experience, both has to put same efforts to learn Pig because it's a completely new API. It's a command based, and among all the ecosystems, the simple and easy ecosystem to learn is Pig only. It's very beautiful, easy to learn, easy to code, easy to understand the code, easy to debug the code. Hive is good for the people who came from SQL background, and SQL is having basic SQL knowledge is very, very helpful, guys, to learn big data. Because if you see in my current project, all the guys are from MSBA. They don't know anything about Java or even any other things. They all are working on Hadoop because we are more on Hive and Spark. So they are still without knowing Java, without knowing even they don't know MapReduce architecture completely. Okay, at certain extent, they are all very good. But still they are all able to work on Hadoop and they are all very good on Hive part, Hive and HBase part, Scoop part, Woozy part. Okay, but this is Hive is something who are good for SQL based. So we know, right, mostly guys who are migrating from mainframes or data warehouse systems means that these guys will be, these resources are more competent on an SQL background. So it's easy for them to work with Hive. Not only Hive, even HBase also you can do through querying. Cassandra also you can do through query based. Impala also query based, and even Spark also you can do through query based. MongoDB also you can do query based. So most of the ecosystems are query based. Okay, HBase you can do work with query based. They have the query engine. Okay, I'll come to that second. Okay, HBase you can do the implementation SQL, you can do implementation Java, you can do an implementation Python, Ruby, Cassandra also you can do in Java, you can do in SQL. So Cassandra has its own query language, CQL, Cassandra query language, same like SQL, same syntax, same keywords, everything same. Okay, so that's why having basic SQL knowledge is very good, guys. You don't need to worry, don't need to know PLSQL. Forget about, we don't see any stored procedures, functions, all these things here. Basic SQL, just writing select queries, joins, filters, groupings. Okay, is good. It's a good. It's good having that knowledge on that basic SQL when learning the ecosystem. Okay, so like this, Hadoop have many ecosystems. Not only that, guys, even if you go for Hadoop, we have many Hadoops available in market. So Sai Kiran asked a question here. Okay, he's asking in real time, what is the real challenge in data analytics? The real challenge is learning these ecosystems. Okay, so basically, you have to learn more ecosystems because when you go to data analytics field, you will see vast types of data, vast volumes of data, and vast types of data. And implementing the algorithms in ecosystems is also real challenging. That's why Spark is getting a little familiar because Spark has inbuilt algorithms implemented already, which has in R, Mahout. Mahout is also one of the ecosystems, machine learning library. So all these machine learning libraries, what is there in Mahout, R, right? They're all implemented in Spark. Okay, so Spark is, I mean, you don't need to implement again. You can directly use those libraries for doing data analytics. And most important, most challenge in data analytics is, in big data or any analytic tools is performance tuning, guys. Performance tuning. Hadoop gives the performance, but we need to tune it. By default, okay, with default configurations, with default implementation, it will give some default tuning, default performance. That's it. I mean, if you want to see the better performance, we have to play a lot with the Hadoop configurations because the performance also depends upon the what is the cluster your setup, what is the hardware used, what is the hardware configurations, what is the RAMs, what is the CPUs you use, and everything. So there will be a lot of constraints will be there in terms of hardware, maybe due to budget or something. So in that case, we need to start tuning from the application side. But Hadoop has all these things. And most challenge again in Hadoop is debugging. I'm telling in front, debugging is most challenge part in Hadoop. So it will take at least 1 month, 2 months to get comfort with the debugging of Hadoop because the Hadoop don't have any debugging suite inbuilt. There is a more manual debugging. Okay, even identifying the issues, finding the root cause analysis, doing the root cause analysis is something. It's a typical, but will be very interesting, guys. Even if it's a typical, it will be very interesting in Hadoop. Okay, so basically it's a time-taking process. Okay, but now some third-party companies are still trying to build some debug suites, testing tools for Hadoop. We have to see. Okay, and also remember in Hadoop there is no something called as of now recently started, but before there is no something called Hadoop tester role. In Hadoop, what kind of roles we have is Hadoop developer, Hadoop analyst, and Hadoop admin. Hadoop developer is pure techie. Hadoop analyst is something he will have knowledge on the ecosystems as well as some business knowledge. It's more like a business analyst. Okay, but they should have knowledge on Hadoop ecosystems and Hadoop cluster and everything a little. And Hadoop admin completely for cluster management. Okay, and Hadoop tester, right now we are normally companies are using the existing QA guys, okay, who are from the QA background. They are giving some base training on Hadoop because they don't need to know how to implement the things, right? They just need to know how to use the things while doing the testing. Okay, they should have some, again, it's also actually in Hadoop, testers will have very challenging role compared to developers. Developers, if they know the things, they'll develop. As I said, debugging is very tough job, right? So debugging and doing the root cause analysis and finding the issues. So that part will be done by testers only, right? So they do face. That's why For testing, they will give more time. Okay, for development, if it take 2 months, for testing, they will take 3 months. Even performance tuning, again, they will take some 2-3 months. Okay, I will discuss more about these parts, okay, in the later classes. So again, okay, so give me 10 more minutes, guys. I'll wind up the demo. So again, in Hadoop, we have different Hadoop distributions available. We have different Hadoops are available in the market. It's not a single Hadoop. You guys may heard, I don't know. There is something called Apache Hadoop, which is a core for all Hadoops. And we have something called Cloudera Hadoop. We call them as distributions. And we have something called Hortonworks Hadoop. We have something called Mapper Hadoop. We have something called Pivotal HD, Pivotal Hadoop distribution. And we have something called, what is that? Greenplum Hadoop. Okay, Greenplum Hadoop is there. Greenplum Hadoop is there. And also we have IBM Hadoop, IBM Big Insights. We have Oracle Hadoop, Oracle Big Practice. Oracle Big Practice. And even, what is that? Microsoft Hadoop, Microsoft HD Lights. We have ETL Hadoop. And like this, still we have few more guys. Amazon Hadoop, Amazon EMR and S3. This is Amazon Hadoop. We have like this, many Hadoop distributions are available. We call them Hadoop distributions. So what is the difference? What we need to learn? Don't get worried. So these are all distributions for cluster setup. Implementation wise, you will use same MapReduce, same Pig, same Hive, same HV, same Cassandra in all distributions. Okay, the code will not change. Okay, the same code, they will use the same implementation you do. So, but these guys will change mainly in the infrastructure. That means the installation process, the cluster management. So it's more for admins the difference. Of course, we also need to know at least some 2 to 3 distributions how they looks like. So in our course, we'll be doing in our laptops or desktops, whatever you guys are going to do, the Apache Hadoop installation. Apache Hadoop installation in real time, we don't use, we use only for proof of concepts and prototypes, but in real time, actual development and production clusters, we don't use Apache Hadoop because I'll talk about Apache Hadoop. But Apache Hadoop is the base and all the other Hadoops are built on top of Apache Hadoop. Okay, so we'll talk about that. And Cloudera Hadoop we are going to do in our course, single node and multi-node installation, that means cluster mode. Hortonworks Hadoop we will do single node installation, and then as I said, we'll be doing Hadoop installation on Amazon Cloud, single node and multi-node. Okay, so we'll be doing all these things. And so what is the distributions? If you want to know what is the distributions, why this many, we need to understand the history of Hadoop base. Maybe give me 5 minutes of time to quickly discuss about the history. Okay, any questions, please stop me guys, don't worry. You can put the questions on the, what is that, chat box as well. So, what is it? So, a person dog carting, right? He is the father of Hadoop guys. Dog carting. He is the father of Hadoop. He is the father of Hadoop. So this guy started a project called Nutch when in 2002. Okay. So the aim of this project is he wants to build a search engine. He wants to build a search engine like Google search engine for distributed systems. Okay, like Google search engine only. He wants to build a search engine. So while he is implementing this project, Google released 2 papers called Google File System and Google MapReduce in 2003. And this guy got inspired from these 2 papers, okay, the way these implementations are done. So he implemented these 2 concepts, Google File System and Google MapReduce in Nutch project. So he started implementing these two project components. Okay, as a file system, as a DFS, distributed file system, and MapReduce, the two modules he re-implemented in Nudge project. Okay, so while he is implementing this in Nudge, Yahoo recruited this guy. He became the Yahoo employee, and Yahoo taken over the Nudge project, and they renamed this Nudge project as Hadoop, guys. And they renamed these two modules in Nudge project as HDFS, Hadoop Distributed File System, and Hadoop MapReduce. And once Hadoop done the complete implementation of this project, then for the release and maintenance of this Hadoop, they gave, for the release management, they gave this Hadoop to Apache Foundation. So Apache started releasing Hadoop from 2007 till now. They are only releasing Hadoop, and we say it's Apache Hadoop, which is open source. And even all the ecosystems also will release by Apache only. Pig, Hive, HBase, Cassandra, Cascading, Kites SDK, Spark. These are all Apache only. Okay, they are all become Apache projects. Okay, but these projects are started by different guys before, but now they are all under umbrella of Apache. Okay, Apache Hadoop is open source. But Apache, even though Hadoop released the Hadoop in 2007 and 2008, but it was not popular for initial some 3 to 4 years. The reason is, the Apache Hadoop, we don't have ecosystems at the time. The first version when the Apache Hadoop released, it has only two things, that is HDFS and MapReduce, and that too MapReduce programming only in Java. So that industry, most of the companies thought it's just like one more Java based tool. At that time, we know Java is very popular, many Java technologies has been evolved. So they thought like one more Java based tool. So I mean, it's not get much recognized. But the Facebook is the first company along with Yahoo started using Apache Hadoop. Facebook is the first company started using Hadoop, Apache Hadoop. And they saw the real pain of doing MapReduce programming in Java to do data analytics on big data sets, on bigger data sets, handling tables like having huge number of columns, having tables data having like GBs and terabytes. So they saw the difficulty, and is the reason what they did is they built a wrapper framework on top of MapReduce called Hive. Hive is by Facebook. They designed a framework Hive, so that anybody without knowing MapReduce, without knowing MR implementation, still they should able to work on Hadoop. So with that motto, they implemented a Hive, and they provided a query interface for Hive. So in Hive, you can do the querying. Through querying, you can do the data analytics without knowing anything about MapReduce. So when Facebook is done that, at the same time, Yahoo also released Pig. So they also build one more wrapper on top of MapReduce, Pig, to simple the implementation part. And then Pig is also, once the Pig and Hive released, then Hadoop started becoming popular, guys. But in the meantime, see guys, okay, in the meantime, Hive is in 2008, I guess, came. Pig was also around 2008 only. So when these ecosystems are releasing at that time, the industry big guys like IBM Big Insights, IBM, Oracle, Microsoft is little late. Amazon, what these guys did is, we know they will have separate R&D teams, I mean the center of excellence teams, right? So what they do, they will identify the technologies. I mean their job is just to see what are the new technologies coming to market and see how to utilize the technology in their projects, or maybe whether they can build any new frameworks on top of that technology, or maybe they can do same kind of any new framework using like that. So they do, right? They will have separate R&D teams, excellence teams. So those guys, so they saw the Apache Hadoop and they saw the benefit of Apache Hadoop. What they did is, Apache Hadoop is open source, anybody can use it, right? So they took this Apache Hadoop and they customized it. Nothing they did. I'll explain what they did. And they made it their own name, like IBM Big Insights, Oracle Big Practice, and they started marketing their products to the customers. See guys, the biggest drawback in Apache Hadoop, right? At that time, even now, Apache Hadoop installation is very lengthy process. It's more manual. You have to run lot of commands to do the installation. And even it's open source. They don't provide you support. If you have any API level issues or something, you can report them. They'll fix it and give in next release. So you have to wait till that release comes. They don't provide support, on-time support. And there is no tools to do the development. There is no tools to debug the things. There is no tools to monitor and manage the clusters. So it's just releasing the solutions. That's it. So these guys used that solution. They customize it, means they did the installation completely automated. So if you just install IBM Big Insights or Cloudera, IBM Big Insights, with double click that product, build, it will install the complete Hadoop in all the nodes in the cluster. Even the configurations it will do automatically. Even the cluster monitoring, cluster tuning, everything will become little simpler. So they did this kind of customization. Even they developed some tools for doing the development, for running, debugging the things, for monitoring the things. So that's how they customized it. So the IBM, Oracle, these guys started marketing their products initially. They did good marketing initially, but later the Cloudera company founded. Cloudera is founded around 2010. So what they did is they also did same. They also took Apache Hadoop. They did complete customization and they did everything what IBM and other guys are doing, and they gave completely at free of cost. So he gave completely the product at free of cost. IBM Hadoop, Oracle Big Practice, Microsoft Hadoop, these are all licensed versions. Okay, Cloudera gave completely the product. Cloudera CDH, Cloudera distribution of Hadoop at free of cost. And Cloudera played a very important role initially in big data marketing, guys. He did lot of marketing on big data. He did lot of trainings on, he did very good. He played important role in big data promotion. And even if you see some ecosystems, I'm saying, right, Impala, Kites SDK, these are all developed by Cloudera. So you will see these ecosystems only when you use Cloudera distribution. You will not see in other distributions. Okay, he did lot of R&D in Cloudera, big data. That's why he has more market in today. But he is also very intelligent. Initially gave it free of cost, he did good promotion. But after 2.5 years, once the companies started using and got addicted to this distribution, he started, costing for this Cloudera Hadoop is one. I'll talk about that. Okay, just give me a couple of minutes. Okay, he started charging, but even though he started charging, Cloudera is free, guys. The software is free even today. He'll charge only for support. If you get any API level issues or any cluster level issues or performance level issues, he will support you and will charge for the support. Okay, they'll charge only for support. Even Hortonworks also do same. Hortonworks also, the software is free, they'll charge for the support. So now the most recognized distribution in market is Cloudera, Hortonworks and Mapper distributions. Okay, these three are most popular. Okay, so that's how these guys are now getting popular. And even the certifications, right? The Cloudera certification is Cloudera and Hortonworks, both certifications are well recognized. Okay, most recognized. Even others are also recognized, but these two are more recognized by clients. Okay, nowadays. Cloudera released a new version of certification just, I think it's releasing today, 6th or 5th, right? It's releasing tomorrow, I guess. Okay, the new version of certification, they are starting from tomorrow. Okay, so in that new version of certification, they are including Spark as well. Before, Spark is not there. Even they changed the pattern and everything. I am planning to do it again. Okay, a new version. So what is that? Yeah. So in our course we are going to see these distributions, guys. So Microsoft, it's a little different. What these guys did is, even the Apache Hadoop, what is there, right? They rebuilt completely Apache Hadoop again using .NET technologies, using .NET and C Sharp. C Sharp and .NET, they re-implemented completely the Apache Hadoop. Apache Hadoop is implemented completely in Java, guys. Okay, is in Java. So here again, Sai Kiran put a question like how different the environments from providers in terms of usage. Usage wise, that's what I'm saying. Developers wise, they don't see any difference in distribution. So suppose now if I give you cluster, Cloudera cluster, whatever you work, suddenly if I give Hortonworks also, you will see similar infrastructure. You don't see any difference. Same code, same configurations, same development tools, same cluster monitoring tools, everything remains same. The difference is for admins. The admins will have a huge difference in terms of installation and uninstallation process, configuration process, mainly the monitoring tools. The monitoring tools will vary. Okay, the monitoring tools and the what is that, cluster management tools. These tools will differ from distribution to distribution. Okay, so developer wise they don't see any difference, guys. Okay, so even you developed a code on Cloudera, if you run that code directly taking any code, Pig, Hive, MapReduce, Spark, any code, if you take it and run it on Hortonworks, it will run it without any issues. Okay, so there are some projects even they do migrate from distribution to distribution. I see the project like migrated from what is that, from Pivotal HD to Mapper. And one of my previous companies, from Mapper again they are trying to Hortonworks now. Okay, and yeah, the distribution changes also happens because there is a cost factor among the distributions. They will choose the one who is charging less and providing good support. Okay, so these are the distributions, guys, and what we are going to see in our distribution, in our course, what we are going to see the installations. Okay, so coming to presentation also talks more about this. I will walk through the presentation in the first session. Okay, so we'll see in the first session. So I will show the course curriculum. So course curriculum, let me show in the, where is that? Not this. Where is the course curriculum? Yeah. So the course is for 70 hours. Okay. So it will take 6 to 7 weeks, guys. Okay, prepare for 7 weeks better, because it may take some extra time, because as I said, more hands-on will be there. Sometimes while doing the practicals it may get delayed. Okay, so prepare for 7 weeks. So in the week 1 we are going to see completely what is a cluster, what is Hadoop cluster, or how different Hadoop cluster. Again, in Hadoop cluster we have different cluster architectures. We have master slave, we have multi master slave architecture. In Hadoop we have different two architectures is there again. Hadoop MapReduce itself we have two architectures, Hadoop Classic and Hadoop Yarn. We are going to see both the architectures. Okay, so we'll be seeing what is the big data characteristics, the characteristics what we discussed now, but I will be discussing in more detail in tomorrow, in the first session. And then about the distributions and the Hadoop ecosystems. Okay, and then we'll be discussing about the Hadoop architecture, what are the Hadoop components, how Hadoop stores the data, what is HDFS architecture, what is the rack architectures, and Hadoop HDFS anatomy, how HDFS data will be written into Hadoop and how the data will be read from HDFS. Okay, and then we'll be discussing Hadoop, something called metadata. We have something called metadata and secondary name node, which is very important. And then we'll be starting the MapReduce architecture. MapReduce architecture we are going to discuss at 3 levels. At basic level, okay, at medium level, and at high level, medium level and low level. Okay, 3 levels we are going to see. So this is all what we will be seeing, the challenges with the traditional solutions, how MapReduce to overcome, what is the performance optimization techniques available in MapReduce. Okay, and we will be seeing some algorithms and MapReduce, like the recommendation algorithms, feedback algorithms, log analysis, okay, searching on big data sets, and we will be doing some data mining on big data. I mean, not through MapReduce, through Spark. We'll be doing, of course, examples wise, don't worry, we have good collection of use cases with solutions, and we'll be doing the installations then in the first weekend, standalone single node installation. Then we'll be doing HDFS practicals, and then we'll be seeing the MapReduce second level of architecture. Okay, and then we'll be doing the Cloudera manager installation, Cloudera installation. Then we'll be seeing the advanced MapReduce topics. Okay, then we'll be seeing that other supporting tools, the Scoop, Flume. Then we'll be starting with the Pig. Okay, after Pig, this is all about Pig only. And then Hive. Hive will be spending more time because Hive mostly 80 to 90% of the projects Hive will be there, guys. Hive is very important. I mean currently. And then Woozy, and then we'll be seeing our ARN architecture, Flume architecture, and then we'll be starting with NoSQL databases. The first is HBase, then Cassandra, then we'll be starting the real-time project, then we'll be doing installation on Amazon Cloud, then we'll be starting Storm, and then Spark. Spark will be seeing Spark SQL, Spark CLI, Spark Streaming, Spark Machine Learning Library, Spark Graphics, and then Impala, and finally the optimization techniques in Hadoop and the compression techniques, and how to do image processing, video processing in Hadoop. And then we'll be discussing some admin topics, the best practices to set up Hadoop cluster. So I will be covering some 60% of admin topics in the development course itself. Okay, and then commissioning and decommissioning, how to add nodes and remove nodes in the cluster dynamically, how to do benchmarking, cluster benchmarking, and what are the admin monitoring tools available in different distributions, and what is a routine admin task, day-to-day activities, what admin does in the cluster. And finally, we'll be seeing the Kafka as well. Okay, so along that, I will be taking one class for Unix practicals, and also, as I said, Java classes will be there, some 8 to 10 hours. Okay, so this is a course curriculum, guys. There is a presentation, and all the course material you will get from Google Drive. So material wise, plenty of material is there. You will get all the programs, exercises along with the solutions and the certification. I will be taking 2 classes for certification at the end of the course, how to prepare for certification, going through the patterns. Okay, I will walk through certain certification questions, and I will be sharing sample resumes as well as all the presentations materials you will get from Google Drive, installation manuals, softwares, books, and case studies, projects. Okay, so it's 100% development. It's 100% development. Yes, 100% development, and 60 to 70% of admin will be covered in this course. Okay, and then what is that? Of course, all the things you'll get from Google Drive, and data, test data, and also all the sessions, the videos will be shared, guys. So once the session, if you miss any class, don't get worried. So on the same day, once the class is completed, next 4 to 5 hours, the recording session will be shared to you from Google Drive. You can walk through it. Okay, and what is that? You can walk through it, and yeah, you can be synced to the next class. And even my course flexibility is something, if you maybe at later sometime due to any unfortunate situation, if you couldn't able to continue the course or something, I will have always 2 batches going. Okay, you can join in other batch for any backup classes, for any missed classes. Even if you if a course is, if you want to again later, if you want to come for complete backup, you are welcome to join other batches. Okay, that flexibility will be there. You don't need to worry. Okay, so these all will be there, and yeah, that is about the course. And regarding the fee and everything, I'll drop you I think I'll discuss you through mails maybe when we talk each other. And yeah, so this is about the course. Any questions? Any more questions if you have? So it's almost like reaching 2 hours. Yeah, course timings. Yes, thanks for reminding. So the course will start morning 7. I'm thinking of 7 or 7:30. Okay. I'll just discuss from all the second batch. Second batch, you mean? For this batch, for the new batch, what I'm starting, it will be either 7 o'clock morning Indian time or 7:30. That I'll confirm you. Either 7 or 7:30. That is confirmed. But among these two timings, I'll confirm you in 1 or 2 days. And the other batch, it will go at morning time at 5:30. Okay. 5:30 morning. I have batch even at 4:30 right now. That is going to finish in in a week. Okay. So that is about the course, guys. Any more questions? I'll confirm you that the timings in a day or two. Okay, to your mail address. It is going to start in 2 to 3 days. Okay, maximum this week itself. It's going to start. Okay, it will start. Maybe I'll plan to start on 8th or 9th. I'll confirm you. It will start in this week itself. Okay. Maybe next week we'll have a holiday for maybe 2 days, guys, because there is a Pongal. So there will be holidays for maybe 2 to 3 days. I'm just telling in before itself. Okay. There could be holidays for 2 to 3 days, but other than that, there won't be any holidays in this month. Okay. We'll have classes on weekends as well. Sundays there won't be class. Okay, but Sundays also I'll plan sometimes. Okay, if you have any installation classes, right, it will take 2 to 2.5 hours sometimes. So in those cases, based on all people availability, I'll plan on weekends. Okay, that's it. So that's it. Any more questions, friends? What is that? So any questions? Hanumant, Hari Krishna, Navneet, Malati, Prasad, Sai Kumar, Kiran, Subraj, I think you know, Sudhir Kumar, Vamshi. So the regular sessions also will start on the same link. Okay, I'm just confirming the timings to your mail IDs. I hope I have all your mail IDs. If any mail ID I don't have, please drop the mail ID here in the chat box. I will take it up. Okay. Hmm. So I'll confirm you in a day or two. Mostly I'll confirm you by tomorrow evening. Okay, the class timings and the date when the course will start. Okay. So thank you, guys. Thanks for a long time. So we'll meet again this weekend to start our regular classes. Okay. And thank you. Uh, sure, Malti. Sure, sure. Okay, see you guys. Bye. Thanks for your time. Good night and have a nice day. Bye. Yes, Prasad, tell me. Hi, Prasad. Prasad, do you want to talk me something? Okay, sir. Okay, sir. Sorry. Okay, sir. Yeah, yeah. I'll send mail to him as well. Sorry, sir. Okay, okay. Thank you, sir. Bye.